Okay. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. My name is Asradi Saka. I belong to the Department of Mechanical Engineering, Hasanuddin University. And today I want to present my last review on catalytic upgrading of bio-oil produced from pyrolysis of biomass over the rice husk as and zeolite catalyst. And this is contents for today, including the introductions, experimental methods, results and discussions, and the last one is conclusions. Let's start to the introductions. As we know that Indonesia have a lot of rice field, not only in 1, 2, or 3 islands, but all islands in Indonesia. And yeah, Asian countries have a lot of rice field, but the problem is they are only open burned in rice field and very close to the household area. So this is the big problem for us. This is the big problem for the Asian countries to utilize how to utilize this raw biomaterial to the renewable energy. And this is the one of the utilized of biomass to energy becomes the bio-oil, or after the bio-oil are produced, then to the upgrade the quality of bio-oil. And this is the pyrolysis reaction process, started from the feedstock as a biomass rice husk, and the sizing and drying into the pyrolysis reactor. There is no air, and in the high temperature 400 to 600 degrees until we got the bio-oil, char, and syngas. But especially for this review and this research, we were analyzed in the bio-oil produced and upgrading using the catalytic. And this is the biomass raw material such as cornstalk, peanut shell, palm shell, and in this review, focus on the rice husk fillet or rice husk. And the research objective, how to obtain the quality of bio-oil after upgrade better than raw rice husk bio-oil produced. And the effects, how to effect the zeolite catalyst as a commercial catalyst, and how to effect the rice husk as catalyst as a non-commercial catalyst. And the originality review, comparison between commercial and non-commercial catalyst, and how to how the impact of the rice husk as a non-commercial catalyst due to presence of large silica content as that compare with zeolite as a commercial catalyst. Let's check it later. And the experimental material and methods. This is the feedstock and catalyst preparations. As you can see, rice husk as and zeolite catalyst have comparison in the catalytic in this research. And rice husks have a lot of silica contents, and we want to check regarding the chemical content in the rice husk as such as carbon, oxygen, hydrogen, and more anything else. And this is the elemental analysis of raw biomaterial. And we want to check it later, how the significantly impact of the carbon, hydrogen, high heating value, moisture content, and oxygen as well. And this is the experimental setup. We were using the two reactors, two heating unit reactors. In the first heating units as a reactor for the raw material, and the second heating units for the catalytic upgrading cracking to the bio-oil produced into the bio-oil upgrade, like in the high temperature as well, of course, 400 to 600 degrees in this research. And the results and discussions, as you can see, rice husk as a feedstock or raw material. After sorting, drying, and pyrolysis in the high temperature, we want to got the char, bio-oil, and uncondensed gas. But focus on this research regarding the bio-oil, how to upgrade this bio-oil produce, how to upgrade this raw bio-oil produce into the upgrading bio-oil in the high quality or using the catalyst. So you want to check the carbon, hydrogen, high heating value, oxygen, and water content or moisture in the next chapter. Before go to the next chapter, we want to check the yield of rice husk bio-oil produce in the temperature range variance. And as you can see, 400 to 450 degrees has a little bit increase the yield. But after 450 until the 600 degrees, wanna decrease and still low yield in the bio-oil. So the maximum temperature in this research are 450 degrees is the best or maximum yield bio-oil. And the composition of yield are mostly phenols. It's like that. And the next chapter regarding the upgrading rice husk oil produce, actually in this part we want to focus to the how to utilize the bio-oil produce to the upgrading bio-oil, and using the two catalysts, two kind catalyst, commercial and non-commercial catalyst. Commercial catalyst zeolite catalyst, and the non-commercial catalyst as rice husk S. And you want to check later how to impact there, right? And the GCMS analysis are how to knowing about the chemical content in the upgrading bio-oil regarding the gas chromatograph and mass spectrometry. Okay, and this is the results and discussions. As you can see, the carbon had the significant high increase before and after upgrading. As you can see, this one, right? And 450 to 400, 45.61 to the 65. And the hydrogen as well, high heating value, I think, a little bit high, increase before and after upgrading. And in another, oxygen and water content, have, I think, successful because has decreased before the upgrading, still high yield of the oxygens, and after the upgrading, 10 to 12 or 15 percentage have decreased. And the liquid product yield by weight, as you can see, the without catalyst still high percentage. After the upgrading using the non-commercial catalyst, decrease until the 4 or 5 something percentage. And using the zeolite catalyst as a commercial catalyst or chemical catalyst, until 7 to 8 percentage. Okay, and this is the GCMS results regarding the two catalysts. And as you can see, the small molecule and phenols are the big areas percentage in this content, and the biggest change of cracking come from the oxygen containing phenols as well. It indicated that the oxidation, the methyl fragmentation, and the isomerization occur on phenols. And let's check to the conclusions. Okay, in the conclusions, in this review, we have checked the two catalysts, and the bio-oil can be upgraded in a process with two heating unit reactors with the zeolite and the rice husk S catalyst. And the second one, rice husk S or RHA catalyst, is a great breakthrough to the frugal in economical, which is the decent quality. I think this research still compare between the commercial and non-commercial catalysts, and the commercial and non-commercial catalysts have a really cheap if we compare with the non-commercial catalyst. I think sounds good to the next level research regarding the rice husk as catalyst. And the catalyst contribute to promote the oxygenation rate or utilization of catalyst results in a decrease of the liquid product yield, including water. And the best organic layer yield was used the zeolite catalyst, and small molecules are the main cause of the catalyst deactivations. Phenols likely deactivate the catalyst. Okay, thank you. This is my presentation for today in the ICMM 2021. And thank you very much. Assalamualaikum warahmatullahi wabarakatuh.